So our first speaker after lunch is John Glass, and he will be speaking on CyberChef. John is a senior cybersecurity associate serving the Federal Reserve's National Incident Response Team as lead malware analyst. He also teaches digital forensics, malware analysis, and cybersecurity Python courses for the University of Richmond School of Professional and Continuing Studies. A 9-year veteran of the United States Air Force, please join me in welcoming John Glass to the stage.
Hi. I have a lot of slides, so I'm going to zip through this pretty quickly. All right. So here's the script for the next 30 minutes or so. I'm going to run through some disclaimers just to give you some and then I will introduce myself and then CyberChef, walk through a couple of recipes of varying sizes to kind of highlight some of the utility of it. And then go into some of the more advanced use cases. This is basically where I took a reasonable thing and took it to a logical extreme, just to see where the limits were. And then kind of round off with some of my lessons learned, and then discuss the overall value that I found from CyberChef. All right, this is the slide that legal made me produce. So the views that I express are my own and not necessarily representative of anything with either my employers or cybersecurity sound advice at all. So view this at your own risk. The second disclaimer is that the bulk of this presentation are things I feel like you should probably do with CyberChef. Then there's another 20% of the presentation where are things you can do with CyberChef, but it might be a little easier if you did it in a different environment. And then there's 5% of this presentation which you should probably not do in CyberChef, but I did it anyways. So and they'll become apparent as we travel through this. All right. So me. I already got my intro. So I lead malware analyst for the Federal Reserve, and I am a adjunct instructor teaching digital forensics, malware analysis, all those classes. The bulk of this presentation was spawned from my work as a professor, where I was trying to find ways to make this easier to transfer this material to my students who had no experience with cybersecurity tasks. So, CyberChef, show of hands, who's used CyberChef before? Everybody? Okay, awesome. So not a foreign concept, made by the good folks at GCHQ. I want to thank them. And also highlight that I didn't make this tool. So, all right. So my goals for introducing my students and coworkers to CyberChef were to kind of lower some of the barriers of cybersecurity learning, especially around the fundamentals, things like base 64 and MD5, and some of the fundamentals that we should all know, but there's no rhyme or reason on how we get this knowledge. So especially for my students, some of the barriers that I found were most interesting were like cost and the perception of how complicated code is, and then just the overall complication of how some of these topics can be overly complicated. And if you just want to teach a specific topic, it gets kind of hard. So my goal was to make it easier for me to teach. So just being a little lazy, I'm looking for the path of least resistance to get to the topics that I need them to know.
Who's speaking first?
All right, so CyberChef. This is the basic interface here. There are 4 main parts. The input box in the upper right is where you can either type or drag and drop files that you would like to process with the operations. The second part is the output field, which is the product of your recipe. The third bar on the right, or on the left rather, is a categorized list of operations that CyberChef can perform in your recipe, and then the middle, where the recipe area is where you can rack and stack your operations to achieve your desired results. All right, so one of the most impressive parts about CyberChef is the number of operations they have. It's over 300, and they're all coded in JavaScript, and I found a lot of them to be very interesting when just combined with each other.
Yeah.
And so going to highlight a couple of small recipes that just to circle around how the tool works. So basically, this is a one operation recipe that's from base64. So in the input box, there's base64 encoded data. In the output box, you get the clear text after it's been decoded. Fairly simple stuff. Here's another one-hitter where we are taking a zip file and we are extracting a file from it, and we're providing a password. I find this to be one of the utilities I use like most often, like on a day-to-day basis. If I quickly need to unzip a zip file and then do something with it, like unzip it and run strings or something like that, I can do it fairly quickly in other ways, Python and command line and whatnot. But sometimes it's easier to just drag it over to this web GUI and run a couple of commands via a recipe. All right. So here I've combined the two previous ones. So the unzip command is being leveraged to unzip the file, and then the file inside of the zip file is base64 encoded, so I need to decode it using the from base64 operation. And then we see the desired result in the output field. Fairly simple stuff. So if we kick it up a notch and use 3 operations, we can do a couple of different things. There are flow control operations that allow you to fork commands across multiple operations. So you take the input and you divide it by a new line terminator, and then you can run the entirety of the recipe against each line of the input. So that gives you some pretty interesting options. Here I'm doing DNS over HTTPS, so I'm resolving a list of host names. And then we're using a JPath expression at the end to kind of give the data we're looking for. So you can kind of see how these operations give you the raw tools to build what you're looking to do. All right, one of the more interesting ones I found was using Yara. I didn't know that you could do Yara in just native JavaScript, so that was pretty impressive. Here is I did a lot of work with Nanocore, so this is the Yara signature for that, and let's see. So those are the smaller recipes, and the idea behind CyberChef is taking those smaller recipes and kind of compounding them and into larger recipes, and or like sharing them out for very specific surgical tactical utility. So here I'm going to take the CyberChef operations and kind of go on a journey where I'm going to deobfuscate a Emotet version 4 downloader. I'm going to skip over the obligatory threat intelligence slide for Emotet. Have anyone here dealt with Emotet? No? Just me? Okay. All right. Pretty common downloader in a Word doc. All right. So if we upload or drag the emotet.doc into the input field, the output field displays the clear text that it can understand, and then it gives dots for anything that's not ASCII. And if we scroll down a little bit, we see the embedded macro inside of the output field. So, but it's clearly obfuscated, and we're going to have a hard time getting any sort of threat intelligence out of that until we either run it in a sandbox or manually parse it. So, also, this presentation quickly turns into a commercial for regular expressions. So, and I did find a way to sneak this into a lot of my classes where I have students that come to me and say, hey, the concept of coding gives me anxiety, but I'm still in your forensics class. And I'm like, I don't know how that happened. But But here, this is a web GUI, it's fine, and we'll just use this something called RegEx. It's not coding, really. It's fine, just a couple of liners here. Yeah, it's cool. So, yeah, I use RegEx a lot in my CyberChefing. So one thing I'm grabbing here is I'm doing a quick capture to see to grab the command and the macro, and the regular expression module here is superb. It lets me just list the capture group. So now I've just got a very succinct. All the other file data has been removed, and I'm just looking at the code that's in the macro. It's still obfuscated though. So one thing you'll notice here is all the carets. This is DOS obfuscation. The caret code is used to escape characters on the DOS command line, but it doesn't really affect the flow control or the flow of the operation. So you can put these all over the place and it doesn't really matter. So I need to get rid of those. So what I use the find and replace, and I just find the carets and replace it with nothing. And now we've got something a little bit more manageable. And let's see. All right, so I'll skip to the interesting parts of this. Basically, what this does is it sets an environment variable with a blob of text that's 3/4 gibberish, and then it uses a command to loop through the environment variable and give me every, it loops backwards actually, and gives me every 4th character. I'm sure you guys can't read that, but you'll have to take my word for it. What I use here is more RegEx to grab the every 4th character. No, I actually just grabbed the what's inside of the environment variable, and then we've just got what's being saved into the environment variable, and I'm going to reverse it using the reverse operation. And then I'm going to capture the 1st character and then skip 3 using more RegEx. And then a pattern emerges where I can now see what the code is supposed to be rendering once it's done with the for loop. So you can see the PowerShell. All right. So now we have the PowerShell that's actually leveraged on the endpoint, and we can glean actionable threat intelligence from this. We can snag these URLs and throw it into our detection. And then one more round of RegEx because it's cheap. And I grabbed the URLs and then voila. So in fairly, one of the best parts about using the manual detection here for Emotet is that traditionally Emotet has had 5 C2 URLs per sample. But when you run it in a sandbox, it'll trigger on like the first one, and so you only get threat intelligence on the first time it reaches out if it's successful. Here we're getting like a 5-for-1 discount, so it's so we get more threat intelligence, so that we can cross-correlate that for campaigns, and so hoorah, manual analysis. All right, and then cool. So from the macro that was inside of a Word doc, I used 8 drag and drop operations and just a slathering of regular expressions, and we were able to extract 5 C2 URLs from this malicious payload. And the cool part about this is that depending on how you write your expressions, this is a repeatable process. So I can take another Emotet version 5, and I did this, I know I'm pretty lame, but I did this for a little bit on the weekend where I would just download samples from VirusTotal, and I would just drag them into this recipe, and it would give me new URLs, and I'd post them in the comments, and I would laugh, and no one was around. But I was giddy, and I had a good time. And then, the next time it worked, I laughed again. It was great. But And so it's, yeah, I have a whole slide about how repeatable it is. And not only is it repeatable for you, but you can share this with, you know, your family and friends. You can give them as gifts. So, one thing I've been doing is the URLs that you visit have the recipes in them, so you can save them as bookmarks. So if you just want to like have a drop down in your browser, just save them as a bookmark, and then next time you want to revisit this recipe, you can just select from that. You can see that down here. All right, so that's a pretty reasonable use of CyberChef, and I took it a little further. And so I decided to see like how applicable CyberChef would be towards building a forensic parser. And so my go-to for learning forensic parsing is the Windows recycle bin, because it's probably the most simple artifact I can think of. We're looking at 4, maybe 5 different fields. Windows 10 switched it up a little bit with a name length, but beyond that, it's pretty simple stuff. So the way the parser shakes out, it's fairly simple. Like on paper, we check to see the first couple bytes. Is it a version 1, version 2? And then we just base our offsets on what version it is. So in CyberChef, it ends up being around 24 operations to get a decent parser. But when it works, it's great. So you can just save it, and you never have to do it again. But 24 it's hard to read because you're looking at a very limited list. You probably only see like 4 or 5 operations on the screen at one time. So here's the other half of that. I put in some error handling and some logic control in there. So, but it is cross-platform, compatible and whatnot. These slides will be available. But the output looks like this. And so I drag in a recycle bin $i file, and then in the output field, I get this output. So it's pretty cool for a one-off tool. If you need to quickly determine, what this is after you've already written the recipe. All right, so pretty easy stuff there. I'm going to get into more advanced use cases. So CyberChef is written in JavaScript, so if you want to write your own your own operations, you can, and I decided to give that a try. But before you start coding in JavaScript to perform DFI or work, you should probably look at this language called Python. It's got a lot more support. There's better memory management and better syntax, and you're not subject to how well a browser can run it. Now, with that being said, I did some other stuff just to see what could be done. So the Windows recycle bin parser in JavaScript looked something like this, and I can't swear that this is great code. But basically this converts the Windows file time object to a date. It converts the UTF-16 to UTF-8, and then converts the file size to decimal. I think it's like 50 some lines, and honestly it could probably be written better, but yeah, so that's what an operation looks like. But once you're done with that, you get an output that looks something like this. You got the same file, and now you can drag over an operation that will do this for you every time. And you just have to kind of recompile your CyberChef to include your new code. And so there are opportunities to add to the native CyberChef code base if you don't want to keep dragging and dropping like 24 operations over. All right. So I also did some things with CyberChef that If you open up Chrome and you disable your web security, you can do fun stuff like integrate CyberChef with VirusTotal. But I'm not recommending this, but it can be done. I did a lot of this stuff in a sandbox, so that's my caveat. All right, so I was using CyberChef to download samples from VirusTotal directly into CyberChef so then I could run recipes against it. So this is just a HTTP request with API keys and whatnot. Fairly simple stuff. Additionally, you can query VirusTotal for reports and use JPath expressions to discern just the information you're looking for. Here I was just looking for the results for, I think I actually took the sample in as dragged the exe into CyberChef, got the MD5, queried VirusTotal for the MD5, and then parsed the results with a JPath expression. All right, so here's something that I don't recommend doing, but you can if you feel the need. During some of my malware analysis, I found it most helpful to run some code through the console debugger while in Chrome because there were some deobfuscation routines that I needed to run the code through before it would actually make sense. So there's this boom p here, boom p, that would process the obfuscated code for me, and then I would put that back into CyberChef and rerun the recipe manually by just interacting with the console debugger itself, so that I think I'm manually triggering the key up event so that CyberChef will keep running, and as I change the code in the input field, it kept going. Any questions so far? How am I doing on time? Seems like I'm blazing through this. Okay, awesome. All right, lessons learned. Okay, it's not ideal for everything. I tried to do a handful of things just to see if it would work. Don't try to parse a whole MFT. It's not meant for that. Don't try to parse a memory dump. Also not meant for that. There are ways to bite off what you can chew. There's operations like take bytes and drop bytes and regular expressions that I'm not getting paid by regular expressions. I just want you guys to know that I get no kickback. But there are ways to make your the workload you put on the browser more manageable, and you'll have a higher success rate. But sometimes you will run into things that stretch the limits of your browser. Honestly, use the right tool for the right job, so please use Python as much as you can. But CyberChef is here for smaller things. I did find that the comment operation is helpful when you're doing malware analysis or anything where you need to keep track of what's going on. I normally leave a comment field at the top of most of my operations and use it kind of like Notepad because I hate switching back and forth between windows. So I just leave a comment field up here, and then Chrome would let me drag it down to make it whatever size I wanted. And yeah, it doesn't affect the operation of the recipe, and it can be saved into the recipe, so it helps kind of clarify your intentions to anyone that you're sharing your operations with. Yeah, as far as sharing goes, when you're including your anything in your blogs, you can use CyberChef to include input and the recipe to in an embedded link, so that if you want to share, like, hey, this is what I was doing at that time, you can share the input and the steps you took to derive the output all in one shot. And I found that really helpful when I'm posting blogs and people want to travel the steps that I went through to get the same results. All right, there's a feature called auto bake. It's turned on by default, and that can sometimes add a little bit of churn if you're in the middle of configuring your recipe, it'll just keep trying to run it every time a change is made. So I often turn that off because it just kind of, and when I'm ready, I hit bake. All right, so overall, the value of CyberChef, I find that it reduces the threshold of cybersecurity tasks. My students are more comfortable with a drag and drop environment, and honestly, having a menu of things to try can be transformative when you don't know anything. You're like, hey, there's a list of things here. I'm going to try, brute forcing XOR and see what happens. And even as a seasoned veteran to these things, like sometimes, it helps to just have a list of things that, you can, maybe it's this. And the web GUI is also just very comfortable, and it's a very safe place for my students to like, oh, okay. It's also a solid platform to demonstrate programming concepts using things like fork and merge to highlight how a for loop would work, and running an operation or a function and then getting the return on it in a window is very visual, and it's very tactile for students, and it helps with taking the abstraction away from coding and giving you something that gives you immediate feedback. Order of operations, and yeah, I think that, yeah, cannot say RegEx enough. Trick students into coding, yep. All right, it's serverless, it's static, it runs client side, there's nothing to install, it works across browsers. It parses your Git parameters, so you can add data, and there's a lot of ways to manipulate that. You can bookmark things, you can post URLs to blogs, and I already covered all that. And it's not overly difficult to customize, even if you are building your own operations. It didn't take me too long to get used to that, and most importantly, it's free. Covered the value, covered the practical applications through a couple of different examples, covered some advanced use cases that are with questionable value, and then I covered some of my lessons learned. I think I have room for questions. There we go.
Pretty good.
Does it run on command line for processing?
It's browser based, it does not necessarily run on command line. I'm sure you could rig something up with PowerShell, but it would just spawn a browser and not necessarily give you the return you're looking for.
So you can't run the rules just separately to get output from the rules? That's a separate process?
I'm not sure I'm 100% following.
Like you just applied a bunch of rules, right?
Uh-huh.
And source data, and you got output data, which you showed. Is there a way for me to script getting that output data from all running rules against input data as like a pipeline?
Oh, okay. Could it be? It doesn't lend well to that. I would say it's more for a user experience than a scriptable experience. Yeah. So I would say no. Off the top of my head, I can't think of a clean way to pull that off.
So my second question, I understand that it's client side, it
Uh-huh.
doesn't require a server. If I have a web server, is there a way for me to say, okay, here's some data that I have on the server, and a user can browse to it on a web server and magically open it? Is there a way to do that?
Yes. Yeah. That's. I think if I'm following, I believe that you can. So you can download it locally and run it on your local machine, or you can post your copy of it to whatever web server you want. And but the files that it's opening are whatever your browser can reach. So if there's a share or something, then that's fine. Yeah, but it doesn't natively like reach out to the resources on a third-party share. You can't. Yeah, I think I'm following, but.
Thanks,
I think it's doable. Yeah.
Is the bad title? I don't know. It's just an ending. No, I mean, forget what it is, but the title is
Correct.
okay?
Yeah, no, that's fine.
You
It is funny.
can, so when you're putting together the Node.js files, there's an operation to recompile it and unbundle it, basically, not compiled in the sense of like a Windows file, but it's just mostly just bundling it so that it's succinctly put together and it's all clearly. I'm an expert at this. Any other questions?
I just have one. Yeah, so you mentioned before that sharing the recipes is useful, especially if you have like different versions of Emotet and stuff like that. Is there any central repository where people actively share recipes for others to look at?
That's a great question. There is a Twitter feed that I was included on where, and I forgot the person's handle, but there is I think there's a Git out there that is sharing recipes. So I'll include that in the slides I put out. But yeah, there are Git repositories for these recipes. I think it's still kind of growing. I think that last time I saw it, it had 20 or 25. But yeah, there's opportunities for more of that. Thank you. All right. If there are no other questions, I will lend my time back.
Thanks.